Okay, in 3.4, we're going to be thinking about the substitution method for integration. But let's think back first about taking the derivative of a composition of functions, because this is where it all comes from. So if we were to take the derivative, that's what this notation means, d dx of f composed with g of x. Remember, what you want to do is take the derivative of the outer function, leave the inner function the same, and then multiply by the derivative of the inner function. But recall, what we want to do is we want to think about anti-differentiation and differentiation, or antiderivatives and derivatives, as being opposites. So if we applied integral to this side, what's going to happen is the antiderivative and this derivative will cancel each other out, leaving us just with f composed with g of x. And then on the right-hand side, we've put the integral with the dx over on this side as well. So basically, we've undone our differentiation with anti-differentiation. So if we got this under control, let's think about what are we talking about with substitution. So what we want to do is we want to pick some u, and we're going to let u equal some function. What you're aiming for is for that u to be the innermost function, the inside function. And then what we have is we have taking the derivative of the left side with respect to x, you would get a du dx, right, using some Leibniz notation there. And then on the right-hand side, the derivative of g would be g prime of x. Now we can rearrange this slightly by moving that dx to the other side by multiplying both sides by dx. That's going to give us du equals g prime dx. All right, from there, what we want to do is basically fill into our function, all right, to our integrand, actually, what's on the inside of that integral to the very right at the top. So what we're going to fill in is we're going to fill in where the gx is. We can replace that with a u. And where the g prime dx is, we're going to replace that with du. All right, but what this is going to do to our function is hopefully it's going to make it a nice, fairly easy looking function that we can integrate. That's the whole point, is use the rules we've been working on and integrate using what we already know. So the steps, we'll definitely go through them with a bunch of examples in this section, and it does take some practice, but the basic steps are you want to pick your u, so you want to pick some innermost function. All right, so you want to pick some u to begin with. Try and make it the innermost function. It's got stuff attached to it. It's under a radical. There are all kinds of different things, but make it the inner function. And then we're going to take the derivative of both sides. Now, we usually jump straight to du on the left-hand side, and we're always going to get this dx on the right-hand side, assuming that's our variable over there. This is the derivative of the right-hand side. Whatever we've chosen for our inner function, okay, is going to be the derivative on the right-hand side. Then you kind of substitute everything in. You get something in terms of u, and then we try to integrate it. At the very end, we want to finally substitute our x's back in using our definition, whatever we called u at the very beginning. So I hope this helps out. We will definitely be going through a bunch of examples to help you better understand it, but this is kind of where it's all derived from, is it's that chain rule, but kind of in reverse.